Welcome to David Alexander Maths Tuition. This is chapter 12F on gradients, tangents and normals. So find the equation of the tangent to the curve y equals x squared plus 5x plus 6 at the point 4, 1, 3, 6. So what we need to remember is the gradient at a particular point on a curve, let's say this point here, the gradient here is the same as the gradient of the tangent at that point. Okay, I've drawn that tangent pretty badly. So what we need to do is we need to work out what the derivative is first of all. So what is dy by dx? Well, it's going to be 2x plus 5. So what is the value of the gradient when x is 4? So remember, this is our function that's turning x's into y's. This, our dy by dx, this is our function for the gradient. This is our gradient function. So the value of the gradient when x is 4 is going to be 2x plus 5. So 2 lots of 4 plus 5, so 13. So therefore the equation of the tangent will be in the form of y equals mx plus c, where we know that the gradient is 13, so y equals 13x plus c. So all I'm going to do is substitute these values in, so 136 equals 13 times by 4 plus c. And now 13 multiplied by 4 is 52, so 136 take away 52 is c, and 136 minus 52 is 84. So the equation of the tangent is y equals 13x plus 84. Find the equation of the normal to the curve. So you've not come across normals before. So here is a curve. Now at a particular point we can put in a tangent, and at this particular point the gradient on the line is the same as the gradient at the tangent that meets that particular point. So let's call this point P. The gradient of point P on this curve is the same as the gradient of the tangent. Now the normal is perpendicular to the tangent. So all we need to do is work out the gradient of the tangent, and then the gradient of the normal is the negative reciprocal of the gradient of the tangent. So first of all, what is the gradient of the tangent? So we need to work out what the derivative is. So dy by dx is going to be 2x plus 3. Now when x is 2, the value of the gradient is going to be 2 times 2 plus 3. So 4 plus 3, so 7. So this tangent here is y equals 7x plus something. We could work out the something because we know it goes through the point 2,8, but we don't need to work that out. So therefore the equation of the normal is going to be y equals minus 1/7 x plus c. Okay, so what we're going to do is work out what c is by substituting in these coordinates, or we can do y minus the y coordinate equals negative 1/7 x minus the x coordinate, which is 2. So expand the bracket, so y is minus 1/7 x plus 2 over 7 minus 8. And what is 2/7? Take away 8, it is minus 54 over 7. So y equals minus 1/7 x minus 54 over 7. Or you can multiply through by 7, so 7y equals negative x minus 54. There we go. Okay, here's one final example. So we want to find the coordinates of the points where the tangent to the curve at the point 530 meets the normal to the same curve at the point negative 314. Okay, so here is our curve, and let's say that this is the point 530. I'll try and draw a decent tangent there. Okay, so not terrible. Meets the normal at the point, so the normal is at negative 314. So let's say that this is negative 314 here. So here is my tangent. Now the normal runs perpendicular to that. Okay, so we can see that they will cross at a certain point, so presumably up here somewhere. So that is what we're doing. So what we need to do is find out the equation of the line for the tangent and the equation of the line for the normal. Okay, so I'm going to need a lot of space here, so let me just delete all the ink. So let's find out the equation for the tangent. So the equation for the tangent, we're going to need our derivative. So dy by dx is 2x. So the gradient at the point 5 is going to be 2 times 5 is 10. So the gradient is 10. So that means the tangent will be y equals 10x plus c. Okay, so let's do our y take away 30. So this is another way, I think I mentioned this in a previous question but didn't really explain why. So you do y minus the y coordinate equals the gradient, and in brackets x minus the x coordinate. So that is going to be 10x minus 50, move the 30 over to the other side. So y equals 10x take away 20. So that is the equation of the tangent. Okay, right, let's think about the normal. So so we know that dy by dx is 2x, so therefore the gradient of the tangent at x equals negative 3 is, well, it's going to be 2 times x, so that is going to be minus 6. So the tangent is y equals minus 6x plus c, so the normal will be y equals positive 1/6 x plus c. So let's do our substitution, or let's just do y minus 14 equals 1/6 of x minus 3, so x plus 3. So expanding the brackets, that is 1/6 x plus 3/6, which is 1/2 plus 14. So y equals 1/6 x plus 14.5, and 14.5, let's just write that as 29 over 2. So there is the equation for the tangent at 530. There is the equation of the normal at negative 314. So where do they meet? Well, we just need to equate these two equations. So therefore 10x take away 20 equals 1/6 x plus 29 over 2. Let's multiply through by 6, so we get 60x minus 120 equals x plus 29 over 2 times by 6, so 87. Oops, don't know why I put an equal sign there, plus 87. Okay, let's subtract an x from both sides, and let's add 120 to both sides. I get 207. And if I divide that by 59, I get a fairly horrible value. X is 207 over 59. And if x is 207 over 59, then y is 10 times that, take away 20. So I'll multiply that by 10 and then subtract 20. Or I could substitute it into the other equation, but the other equation is a little bit of a fiddle. So 890 over 59. And we're done.